Hello, I'm Abranil, and I'm presenting work done in collaboration with Alex, Michael, Nathan, Fanny, Jessica, and Matt. Our paper is titled Multiverse, Multiplexing Alternative Data Analysis in our notebooks. There was a study published a few years ago claiming that hurricanes with more feminine names tend to cause more deaths. Following this, there were several other studies which found that this was not actually true. To understand what actually happened, let's dig into the original analysis. Like any data analysis, after the data has been collected, the original analysis started by loading the dataset. Next, they decided to remove outliers. In this case, they removed the two hurricanes with the largest number of deaths. Seems reasonable, right? Well, why did the authors of the original analysis choose to remove two data points? Why not just one? Why remove any outliers at all? Let us move on. Next, they used deaths as the criteria for removal of extreme values. Could they not have removed extreme values based on the amount of damage that a hurricane had caused instead? Another choice was the regression model that they had used. And another was the choice of predictors. At this point, you probably get the picture. The authors made a bunch of decisions in their data analysis, but they very well could have made an entirely different set of decisions. If they had, what might have the result been? A multiverse analysis involves performing and reporting all combinations of reasonable alternative choices in the data analysis to see whether the estimates are consistent across all these analysis paths. In other words, the goal of a multiverse analysis is to see if your result is a 1 in a million, or if it is part of a consistent larger pattern. To help users implement multiverse analysis in a more efficient manner, we developed the R library called Multiverse. To show how it works, let's return to the example of different choices for excluding outliers. Let's say we want to consider two options, removing no outliers or removing one most extreme value as outliers, in addition to the option that was taken in the original analysis, which was to exclude the two most extreme values. In Multiverse, this can be implemented using the branch function. A branch defines a decision point in the analysis. The first argument of the branch function denotes the name of the decision. Subsequent arguments of branch involves declaration of alternate analysis. The Multiverse API will take this declaration and create three distinct analyses, one for each of the options of excluding outliers. You can find more details in the paper on how we implement the library and the optimization that we perform for executing the different analysis paths. We also provide examples on how to use the library to implement multiverse analysis in the paper, as well as extensive documentations on the R package website. But to summarize, Multiverse is a metaprogramming language for R. It integrates with Markdown and R scripts to fit into existing workflows of users. It is close in syntax to the existing paradigms of how users program in R. It supports all types of decisions that one might want to specify in a multiverse analysis through a flexible and extensible syntax. It retains the context of the code in which the decisions are being made. To evaluate whether we were able to achieve these design goals, we conducted a user study with 3 researchers. All of the researchers were familiar with statistics and R, and they were using the Multiverse R library to implement a complete analysis for their research project with the goal of submitting the study to a peer-reviewed venue. Our participants also had very different backgrounds. The first participant was a graduate student in psychology. The second was a graduate student in medicine. And the final participant was a graduate student in computer science. From our evaluation, we found that the researchers were less likely to brainstorm alternative analysis paths while implementing their analysis, which was something that prior work investigating data analysis workflows in more general settings had observed. Instead, all researchers engaged in extensive planning to identify degrees of freedom from prior work. They then implemented their multiverse analysis in code. But they did use an iterative workflow to refine and modify their code to implement their planned analysis. To learn how to use the tool, all researchers started with the documentation that is provided with the library and iterated on it until they were able to specify their desired analysis. All researchers stated that translating the conceptual decisions to multiverse syntax was generally straightforward, indicating the expressivity of the library. Finally, two of the researchers had mentioned facing issues in debugging their code, suggesting the need for dedicated tools to assist in debugging. To understand the debugging issues that the users of Multiverse faced, it's helpful to understand how Multiverse provides error messages. Say a user has executed an analysis in Multiverse which contains errors. The library will provide the users with a traceback. The traceback will indicate the universe in which the error has occurred and a message indicating what the error actually is. However, if there are many universes in the analysis and a large proportion of them have errors, this can quickly get overwhelming. Other multiverse tools also face similar issues. Boba, another tool which lets users implement multiverse analysis, is executed in the command line and prints error messages from every universe directly into the command line. In our paper, we discuss feature design ideas for debuggers, which can leverage interactive visualizations and show users errors and warnings in real time. An example is imagined right here. In implementing the multiverse, we also made particular design choices. We used a branch function as an universal operator for multiplexing and declaring alternatives. This makes it very flexible and allows us to support every type of usage scenario that we could think of, but there were some trade-offs as well. For example, consider this code which excludes all values of x, which is more than 2 standard deviations away from the mean. This is a common way of excluding outliers. But the choice of 2 times the standard deviation here is somewhat arbitrary. Prior literature says you can use 2.5 or 3 even. One way of implementing this branch through our API might be to have the predicate x less than mean x times the 2 times standard deviation inside the branch statement, as well as the alternatives. Another might be to have the entire filter function inside the branch statement, which is more verbose. A minimalist might prefer this approach, which uses branch to only change the values 2 or 3. This creates a potential gulf of execution. As there are many approaches of achieving the same goal, can the user figure out any of these approaches? Stylistically, are there any approaches which are easier to read or easier to learn? A contrasting example is provided by mverse, which is an API that is built on top of Multiverse. It provides analogs of existing functions as multiplexing alternatives. Thus, instead of using the filter function, the user would have to use the filter branch function in mverse. This makes it easier for a user who is familiar with the regular function of filter to implement the multiverse analog, but creates a challenge if they are trying to implement something in novel scenarios, as mverse may not support it, and is not flexible enough to be adapted for use in new ways which the creators have not yet identified. For instance, what if there is no analog that exists? Our evaluation with users suggested that they were able to use this branch function as an atomic unit to successfully implement complex multiverse analysis. One user was even able to create a new usage pattern that we had not explicitly designed for. So to conclude, our approach of using branch as an atomic operator appears to support flexible and expressive construction of multiverse analysis. With that, I conclude my presentation. The data, code, and preprint for this project can be found at this OSF link. The multiverse library is available to be downloaded on CRAN, and this research was supported by these NSF grants. Thank you.